Hi guys, in this session we're going to combine the index laws and we're going to have them all in together this fine weather. So fortunately there are a couple of steps that you can use as a strategy which tells you what to tackle first when you've got this whole thing looking you in the face and confronting you and scaring you half to death. It makes it a lot easier and it turns it into a cookbook procedure. So let's go with it. We'll do one example first and then I'll show you this beautiful little strategy which you can use as part of your mathematical toolkit. So when we're combining the index laws, in most practical situations more than one index law is required to simplify the expression. And the following examples show simplifications of expressions with indices using several index laws. Well, we'll do this one first and then I'll show you this strategy, okay? And I think you'll like it. So with number A, what have we got? We've got 2a to the power of 4 times b to the 4 over 6a cubed b squared. Well, what would you do first, guys? Let me just ask you that question. Have a look at it. Well, what I would do is I would multiply that bracket out first, okay? So I would call that 2 to the 4 times a to the 4 times b to the 4 over the same denominator. And then what I would do then is I would find out what this is, because I can actually work out what 2 to the 4 is because it's an actual number. That's probably the next step I would take, okay? So I would call that 16a to the 4 times b to the 4 over 6a cubed b squared. Now, the numerator is about as simple as I can get it, and the denominator is the same as we've been using all along, already simplified to its maximum level. What I'd start to do now is I'd start cancelling top to bottom, okay? We could start with the numbers. 2 will go into the 16 and it will go into the 6. So 2 into 6 goes 3, 2 into 16 goes 8. Now, let's do the pronumerals now. We've got 3 a's multiplied by each other here, a times a times a. We've got a times a times a times a. That's 4 of them up there. So 3 of these will cancel into 3 of the 4 there. And that will just leave a on the numerator, okay? What about the b's? Well, we've got 2 of them multiplied by each other here and 4 of them multiplied by each other here. So 2 of these will go into 2 of the 4 there, leaving another 2. So we'll get b squared left on the numerator for the b term. Now, we better just do a clean-up line now and see what we've got. I think we will have 8a b squared over 3. Okay, 8a b squared over 3, and that's our answer. Okay, you like it? Not so hard really, is it? Now, this one, this b, gets a bit interesting. So let's have a look at it. What have we got? We've got 3 to the n minus 2 times 9 to the n plus 1 over 81 to the n minus 1. Well, I know, it looks pretty horrifying, doesn't it? But there is something very simple you can look out for with this kind of thing. Do you see how 9 is a multiple of 3? And 81 is a multiple of 9. In fact, it's also a multiple of 3 because 9 is a multiple of 3 in and of itself. So why don't we express these bases as powers of 3? Okay, that'd be the first step I would do, and I'll show you what I mean. So I'd call that 3 to the n minus 2, that's unchanged. This one is 3 squared to the n plus 1, and this is 3 to the power 4 to the n minus 1, okay? Now let's just multiply these brackets out now and see where we end up. We've got 3 to the n minus 2, that's the same as in the previous line, times, what have we got here? 3 to the 2 times n plus 1, haven't we? Okay, and that's therefore 2n plus 2 over 3 to the 4 times n minus 1, which is 3 to the 4n minus 4, guys. Okay, now, because we've got these bases the same, you see there was method in my madness. I got the bases the same, therefore I can use the index laws. When I'm multiplying this by this, I simply add the indices together. Okay, so let's do that. On the numerator, we get 3 to the n minus 2 plus 2n plus 2 on the numerator, and we've got the same on the denominator as we had in the previous line. So let's clean up that numerator now. What is that going to be, guys? You do that now in your head for me, and what do you get? Yes, you get 3 to the 3n over 3 to the 4n minus 4. Now the question is, ladies and gentlemen, what are we supposed to do with that? Well, what you could do, there are several ways of approaching it, and all roads lead to Rome, hopefully, and Rome is the right answer. This is what my approach was. I just said, all right, well, I can call that 3 to the 3n minus this whole thing. Yes, that's the second index law, enables us to do that. And that would get us, when I remove that bracket, multiply that bracket out with the minus 1 in front of it, being very careful with the signs here. You've got a double negative, be careful of that. You've got 3 to the 3n minus 4n plus 4, ladies and gentlemen, okay? Now just cleaning that up a little bit, okay, with that 3n minus the 4n, which gets you minus n, we've got 3 to the minus n plus 4. Now that's a perfectly correct answer. You could, if you wanted to, you could fiddle with that a little bit, and if you wanted to have maybe a bracket there, you could, to have a positive n inside the bracket, you could go minus, open bracket, n minus 4, close bracket, right? Now, the reason that you might want to do that is that then you could use the index law to express this n term here, this n minus 4 term here, I should say, with a positive index. So you could then go, okay, that's 1 over 3 to the plus n minus 4. And that would be also perfectly acceptable. But this is equivalent to this, and it's also equivalent to this. They're all equivalent to each other. Okay, guys, that was a pretty interesting one, wasn't it? Now, as promised, here is my strategy for you, telling you how you can deal with these things and what order would be a good way to deal with them when you've got these combinations of index laws involved, all right? So the first thing is, where there are brackets, I would multiply these out first. I always do that, and it works like a charm. Secondly, if the expression is a fraction, okay, it's got a numerator and a denominator, I always simplify the numerator and the denominator as much as I can first, and then I do my final cancelling and simplification between the numerator and the denominator after I've simplified each of them individually as much as I possibly can, alright? And the third thing is that usually we express the final answer with positive indices, okay? With positive indices. Alright, let's do some examples now and see whether we really understand how to tackle these fairly grisly looking questions. So have a look at this. Number A, we've got this one here. Alright, now the first thing to do is to multiply out that bracket, okay? So let's do that. We've got 2 to the 4 times a cubed to the 4 times b to the 4. So there it is, 2 to the 4, which happens to be 16, because we can do that because that's an actual number, that base. That's going to end up being a to the 12, isn't it? Times b to the 4 times all the rest of this stuff unchanged. Now, in the next line, what we can do is we can call that 2 to the 4 16. We can call that a to the 12. I think that's all I would do. Okay, looking pretty good. So in the next line, what would you do, guys? Well, what I would do is I'd multiply this by this as the front term. Okay, they're both numbers, so we can do that. That'll get us 64. Then I would take the a's. Okay, that's with the base a. We've got a to the 12 there and a to the 2 there. So I would multiply them together as a to the 12 plus 2. Okay, and then I'd take this as b to the 4 plus 3. There it is for you. Okay. Now, one more line of simplification and we are there, guys. That's just adding this up to get 14, adding that up to get 7, and you've got that, and Bob's your uncle. Nice, huh? Very, very nice. Line by line, that's the way you go. Remember that inch by inch, anything's a cinch, but mile by mile, it's a terrible trial, and that's not the way you do these things. You just whittle away at them bit by bit. and it really doesn't matter how many lines you take to get the answer. As long as you just take one little chunk at a time and keep your head, you'll be fine. Alright, 7xy cubed over 3x cubed y squared, all in brackets, squared. Alright, well, what is our cookbook recipe, our strategy? Get rid of that bracket first, guys. So that's 7xy cubed over 3 squared times x cubed squared times y squared squared. Alright, now, what we can do now is we can basically just simplify this now in our next line, like that. 7xy cubed over 9, 3 squared is 9, x to the 3 times 2, which is x to the 6, times y to the 2 squared, which is y to the 4. Alright? Now, this is about as simple as this can get. This is about as simple as this can get, so now we can do what I call the battle of the top and bottom. We can cancel term by term between the top and the bottom to get to our final result. Alright? Now, let's have a look at it. What can we cancel? Well, we've got some x cancelling and we've got some y cancelling. So let's cancel the x's. What would be the result of cancelling the x terms, guys? Well, you would get that. Do you agree with me? X to the 5. And what about the y terms? What would be the result of cancelling there? Well, you would just get a y, because y cubed goes into y to the 4, y times. These 3 y's here cancel with 3 of the 4 y's there, leaving one of them left over. So our answer, ladies and gentlemen, looks like being 7, nothing else there, 7 over 9 x to the 5 y. Let's do that. And it is a beautiful thing. It is truly a beautiful thing. Yes? Are you feeling a bit more confident about it now? Remember, you just chug away at them bit by bit with that strategy in place, guys. So what have we got here? We've got C. Looks not too bad. So what would you do first with that? Well, I think I'd combine these m terms here and these n terms here on the numerator and do the same thing, consolidating here on the denominator before I do the battle of the top with the bottom. So we've got 2 times 3. Okay, 2 times 3 is 6, m to the 5 plus 7 here, and n to the 1 plus 4 on the numerator. We've got a 7 there, m to the 3 plus 1. This is m to the 1, remember here. If it's not stated, you just know it's a 1, the index that is. And this is n to the 3 plus 2, which gets you n to the 5. But let's just state that in the next line. 6 m to the 12, n to the 5, over 7 m to the 4, n to the 5. Alright guys, the battle of the top and the bottom now coming up. Where can we cancel and what do we get? Well, let's do the m's first. Now, you would get m to the 8 on the numerator, wouldn't you? Yes. And with the n terms, they cancel each other out completely, okay? With nothing left over except 1's. So there's your m's and there's your n's, alright? So what is the answer? It is 6m to the 8 over 7. And we're in heaven, aren't we? Alright, it's great, isn't it? So, let's not get too overconfident here. This looks pretty gruesome. But look, we'll use our strategy and we will get these where we want them, won't we? Okay, so here comes A. There it is. What a beast. Well, what does our strategy tell us to do, guys? Yes, multiply out the brackets first. So we've got a bracket on the top, we've got a bracket on the bottom, and we've got to sort them out. So let's do the next line. 5 squared times a to the 2 times 2 times b to the 3 times 2 over a to the 10, all multiplied by, okay, the numerator of that second bit is the same. The denominator becomes a to the 3 times 7, b to the 1 times 7, which is just b to the 7. Alright, so let's clean that up a bit now. The 5 squared is going to get us 25, and it'll be a to the 4, b to the 6, times a squared b to the 5, all on the numerator, over a denominator which will be a to the 10 times a to the 21 times b to the 7. And there it is, guys. Now we better consolidate the numerator with the a's and the b's there, and the denominator with those a's before we do the battle of the top and bottom, alright? So we've got 25 times a to the 6 times b to the 6 plus 5 over a to the, goodness, 10 plus 21 times b to the 7. All right, we'll clean that up a bit. There it is. Does that look right? 25a to the 6, b to the 11, over a to the 31 times b to the 7. All right, here we go, guys. Battle of the top and the bottom coming up. Now, it'll be 25, and the a term will be on the bottom. It'll be a to the 25, and the b term will be on the top. It'll be b to the 4. Okay, keeping positive indices. That's what I'm doing, all right? So, yeah, there's your a to the 25 on the bottom, and there's your b to the 4 on the top. Excellento, and there is our answer, and we're feeling mighty fine. Yes, 25, b to the 4 over a to the 25. Ladies and gentlemen, take a bow. Yes. All right, now, here's b. A beastly looking thing. There it is. Now, this is something we haven't talked about before. When you have these things, you're dividing by a fraction. Look, guys, the very first thing you do before you do anything else is you invert this and multiply. Okay? Don't do anything until you do that. Okay? So that is our next step. Do you see how I've done that? I've just turned that term upside down. This was the denominator up here, it's the numerator here. This was the numerator here, it's the denominator there. Now, this is really our starting point for sorting this out, okay? You've got to have multiplications here, otherwise you get extremely confused. Now, what's the very first thing we should do? Well, having a look at it, let's get rid of the brackets. That's what our strategy tells us. So this is the culprit here we've got to deal with, guys. So let's do that. We've got, this is unchanged from the previous line. This is changed. It's 6 cubed times m cubed times n squared cubed. And this term is the same as it was on the previous, this bit here is the same as it was on the previous line. Okay, so we can probably clean that up a bit now and just call this n to the 6. Probably that's the only change I'd make there on that line there. Now have a look at it. Does it look right? Yes, it looks fine. Now, what can we do to that? It's a mess, isn't it? My goodness. Well, I think the strategy tells us we should basically consolidate the top here and consolidate the bottom here before we do the battle of the top and the bottom. So fear not, it's all working out fine. So, what have we got on the top? We've got 8 times 6 times m to the 3 minus 5, yes that's right, n to the minus 4 plus 1, remembering that this is a 1 here, guys. And on the bottom we've got 6 cubed times 4, they are the number terms, which we normally put first on the line, and then we've got m to the 3 minus 2 times n to the 6 minus 4. Goodness, don't lose your head now, come on, stay strong, it's going to be easy from now on. Consolidate all this stuff with these indices, I think, and that's what I would do there, yes. Don't do too much at once, otherwise you'll overload your working memory. So therefore, we've got, okay, 8 times 6 times m to the minus 2 times n to the minus 3, good show. 6 cubed times 4 times m to the 1 times n squared. Alright, that looks alright, doesn't it? Now what are we going to do next? What would you do next, guys? Well, it's very interesting because what I think I would do, seeing that we've really made this about as simple as we can apart from multiplying these terms together, which I'm not going to bother about because there'll be some cancelling with these number terms top and bottom. Probably we could take the m term down here as m to the plus 2 and the n term similarly down here as n to the plus 3 and see how that looks. There it is. Goodness, how amazing. Well, now we've got to consolidate the denominator here as m to the 3 times n to the 5 and we're going to do some cancellation of the number terms. It's time, guys. So this 6 here is 6 to the 1 and that divides here, cancels here I mean, with this 6 cubed to give 6 squared because the 6 here cancels with one of the 6 terms here, of which there are 3, yeah, leaving 2. So we've got 6 squared down here, and we've got also, we can say that the 4 will cancel into the 8 twice. Okay, I think that takes care of our number terms now, doesn't it? We're going to end up with 2 over 36, and of course that'll then become 1 over 18, but we'll do that in the next line down, I think. So, alright, I think it's time for the next line, don't you think? So it's 2 over 36 on the, look, there's only 2 left on the numerator, over 36 times m to the 1 plus 2, n to the 2 plus 3, okay. 2 over 36 m cubed, n to the 5, and the 2 over 36 becomes 1 over 18, and my goodness, we did it. My goodness, guys, take a very big bow and a pat on the back for you. Isn't that great? You see, we can do these things, providing we just do line by line, and we keep our head and we follow our strategy. All right, over to the remember bit, and then we can finish up. So we're saying that simplifying expressions with indices often involves application of more than one law. Yes, of course they do. Secondly, we can say that if an expression contains brackets, they should be removed first. And if the expression contains fractions, we simplify first of all the top and the bottom, and then we do the battle of the top and the bottom. That's what point 3 is actually saying. And then point 4 says when dividing fractions, we change the division to multiplication. Yes, that's very important. And then we flip the second fraction by multiplying instead of dividing. That's right. And we saw that in that last example, didn't we, guys? Yes. And then point 5 says express the final answer with positive indices. And we're laughing very, very loudly and patting ourselves on the back. All right, well, I hope you had a good time, and we'll see you soon.